Hello everyone, this is Mr. Rege, and today I'm going to demonstrate how to create a gyroscope, a little rotating device that literally maintains its own gyroscopic axis for a while, as long as it rotates. And this is the very elementary essential member of multiple systems in our in the cruise ships, in the planes, jet planes, rockets, and the basic concept of the gyroscope applies pretty much in physics and engineering world, architecture, and international travels. And this is also can be used by students, and I'm just going to simply demonstrate how to do it in the Inventor. The same project can be accomplished using AutoCAD as well, but this AutoCAD, I don't have the instructions for that, but I'm creating these instructions in the Inventor. All right, so first please start Inventor, 2023 or 2022, whichever is available to you, and this is going to be a part drawing. There will be perhaps 1, 2, 3 drawings, okay, altogether. The first part is going to be the cap, the second part, the body of the gyroscope, and the third part is going to be the assembly. Okay, so if you move on and click on the new button when you start the Inventor, it will give you a bunch of options, okay, and either you're going to go to English metric or metric system. My dimensions are in inch system. I'm using mostly inch system since I came to the United States 40 years ago. Metric system utilizes millimeters. Right now, English system, inch system is fine. And you're going to be generating standard inch system IPT, or short for Inventor Part Drawing. Create. Okay. The software will generate the part drawing, and as soon as the part drawing is in front of you, you move your cursor over the origin as usual. One of the things perhaps to do to just double check the inch system, whether it's go to the tools, document settings, make sure that the units are inch and pound system is in place correctly, and you can choose XZ plane or YZ plane or XY plane. I will go with the XZ plane option. Click on it. Okay. And the first things are first. We want to generate the lines initially, and for that to happen, I'm going to use a rectangle, okay, and this create a rectangle of let's hit the tab key. The height of the rectangle is going to be 3/4 of an inch, 0.75, and hit the tab key again, and the width of the rectangle will be 0.125. Okay, enter. Okay, so this will be the handle, and I'm suggesting you zoom in and fit here a circle. Click on the circle command and generate a circle, and perhaps you should move the circle down a little bit from where it is. To move the circle, use the move command. select the circle, and then choose the base point, okay? And of course, the dimensions are generated already. You want to create and erase the dimensions later on. And okay, we can literally trim the half of the circle. After we're going to do this after moving the circle. The fact that when you generate, computer also creates constraints, and that ties everything together in one piece. And we will that limits your things that you can do. So that's why I'm going to extend the line over here, and I'm going to then trim, okay, the circle, the arc, and everything. Okay. I will draw, this circle is a little bit smaller than what I expected. I'm going to make it a little bit larger, okay, and erase the other circle. And I'm going to use extend command, as I already used it, and then I'm going to use trim command, okay. All right, so far so good. What else can I do? I can use again line command. All right, so I'm going to select this point and we'll go 1/8 of an inch, 0.125 up. Okay, from here I'm going to go down from where I left, 0.43, so 0.43, enter, and I'm going to go right, again 0.43 to the right, okay, and then I'm going to just join the last point with the first point, okay. So this is the shape I have right now. This is going to will be the cap of the gyroscope, and I'm going to use trim command here, trim command, and because the dimensions can be in the way, I'm going to erase them. Okay. Okay, so I think we're almost there, and I finish the sketch and go to 3D modeling and use the revolve command. It's already selected. Select the axis, select the vertical line, click axis and then vertical line. And revolution is made, 360 revolution. One of the things you can do at this point, use the fillet command. Okay? And I'm just going to just do that and use the fillet command. All right. To avoid the sharp corners. So far, so good. Material has to be selected. Malleable iron. Okay, this is a good material, pretty sturdy. And then you need to save it. Okay, the student drive, OneDrive. Please save it only only OneDrive. Do not save it in your computer. Do not save it anywhere else. Okay. That's the safest place you can save. And I'm going to save it in where I am allowed to save. Save as. Okay. And it's going to be gyroscope. Okay, so far so good. Now I'm going to select the bottom surface. Okay, the surface, the plane that I selected, allows me to create a part drawing, sketched from there. So now sketch is created. On the sketch, I want to create a hexagon. Okay, I go to rectangle, under the rectangle, go to the polygon. Polygon is six-sided hexagon. And I'm going to choose the center point, okay? And the hexagon is going to have the diameter of 1 inch. How can I be sure? I need to measure it, okay? I cannot be sure without measuring. So 0.865 is a good number, 0.865 this way. But I want to make sure that from corner to corner distance, align distance, 1 inch. So that has to be 1, enter. Okay. And the between two lines is 0.86. So this is good. I think this is exactly the size, correct size. If you want to measure two parallel lines, that's 0.86. 0.866. Okay? I'm just putting there in case you're curious and you want to do that. 0.86 is the correct number, but I'm not going to use 2 dimensions. It's considered a mistake in engineering world. Okay, so now I'm ready to extrusion. For extrusion, I'm going to extrude 1/8 of an inch. So finish the sketch. You're going to go to extrude, select the item, and 1/8 of an inch is 0.125. Extrude. Good. And now that the extrusion is done, this is going to be the cap part of the body. I'm choosing the plane underneath and creating another sketch. This time I'm choosing the parts that's going to fit inside. Okay. And it's done again. But the dimension will be slightly smaller than, I'm going to go to align dimensioning, slightly smaller than the opening. So what is the dimension going to be? The opening is going to be the 7/8 of an inch. I'm sorry, the opening is going to be 3/4 of an inch. The 3/4 of an inch, 0.75. And if the projection part to fit into the area of 0.75 is the same size, it will not fit in there. So dimensioning and tolerancing is a 1 semester engineering course if you go to school, engineering school. So it recommends you to go like 1/10 of an inch less. Okay. So 0.75, I'm going to go with the 0.65 and slightly smaller. Okay. So 0.65 will nicely fit in there. Okay. It's slightly smaller than 0.75. All right, so now I'm going to extrude this part 1/8 of an inch. Finish the sketch, extrude, and 0.8, and OK. Perfect. And save the design. And design I call Gyroscope-bymrege. And this is the handle. I'm going to go one of the sketches and copy this particular gyroscope. Okay. And I don't need to, but I just want to show you that what you can do from one drawing to second drawing. So this particular second drawing, okay, is going to have a sketch copied. So even though you know the dimensions, I know the dimensions still. We need to, it's a good idea to do this, okay, so from time to time, for the productivity purposes. And so Control C. And now I'm finishing the sketch. I'm saving again. I'm going to go to File and New. This time, again, I'm starting a new part drawing. Okay. And this part drawing, all right, will come again with the XZ plane. You're going to create. And Control V. Okay. And from this hexagon, you're going to generate, okay, extrusion. Okay. So I can suggest you to go ahead and use offset command. And the offset, the smaller hexagon, okay, is going to be 3/4 of an inch. The offset is 0.125. You can use 1/8 of an inch offset, enter, okay? And now we're ready to extrude this part for about 1 inch. And I'm going to go and finish the sketch. As soon as I finish the sketch, I earn the rights to save the drawing. So I go to File, Save As. And this is going to be, again, gyroscope body. So I'm going to just gyroscope body. And I always use my name just to avoid the confusions. Save. Okay. Now we need to extrude it. Extrusion will be little less than 1 inch because I want the total length to be 1 inch. And also what direction, again, is important. And this is the direction, we're going up. 1/8 of an inch less, so 7/8 of an inch. 7/8 of an inch extrusion. Now, in addition to the first extrusion, we're going to have a next extrusion. I'm going to click on the plus button, choose, okay, extrusion in the opposite direction. This time it's going to be 1/8 of an inch. So I'm going to erase 1/8 of an inch extrusion. Okay. So what does it look like? Looks like it's a cup, right? Good. Now we need a cone underneath. So we need to select the bottom surface, create a sketch over there. And how do we create a cone? Oh, this is not the way to create a cone. Yeah. In AutoCAD, you can go ask for a cone, and you can create it. Here in Inventor, you have to construct your cone. So you can't do this way. I can't do this way. So I'm going to finish the sketch, erase this sketch because it's the wrong plane, and delete it. And instead, I'm going to choose a plane underneath. This is the plane I'd like to use. So I'm selecting this plane, okay? And I'm drawing, constructing my cone. And this is going to be a cone of 0.43. So 0.43, enter. Point 43, enter. Okay. So I think finally I've got an isosceles. Right triangle, 0.43 by 0.43. And now I think I'm ready to revolve it, finish the sketch, and go select revolve command, choose the area, it's already chosen. Select the axis option, when revolution is made, okay, all right, that's the way it's supposed to be. Cool. Okay, so that is your body of gyroscope, okay, and you save it, of course. So in the assembly drawing, we're going to join the body. Also, I want to demonstrate how to do the letters on the surface, three-dimensional letters on the surfaces. Okay, I'm not sure if you're aware of it or not, but letters are special meanings, especially in this world of science and mathematics. For example, the 10th letter, J, okay, is a special meaning. For number 10, for example, the names of the orbits around the atom, around the center of the nuclei of the atom, gets the letters K, L, M, N, O, because the first one is K, that's the 11th letter of the alphabet. L is the 12th letter of the alphabet. So instead of using numbers here, we can use letters, K, L, M, N, O, okay? I just want to demonstrate how to do this properly. You select the surface, okay? And create a sketch on the surface, all right? And let's go to text, and choose a text, okay? And we're going to generate letter K here on the surface, okay? I want it to be the bold-faced letters. So the bold-faced letters are not so common. So it's going to be Arial black. Yeah, rounded black bold. And I want this to be centered, justified, middle justified, okay? And what's the size of going to be? 0.125 is too little. Let's make it like 0.4. Let's see, 0.4 is good. Okay, and the letter is going to be K, or 11th letter of the alphabet. Okay. Font changed automatically. So I'm going to go back and find Arial rounded black. Good. All right, 0.4. And let's see how it looks in there. Okay, that's not too bad. And this is 0.4 inches high letter. And I want to just demonstrate that so that you can use your name or use your letters. And now that this is done, you can go to extrude and choose this letter and make the extrusion 1/8 of an inch extrusion. Okay, or maybe even less. It doesn't have to be 1/8 of an inch. You can make it like 0.062625. Okay. Okay. All right. So this is how you do. If you want to write your name, pretty much this is how you do it. Okay. For the second surface, again, same way. You create a plane. Okay. And you simply go to sketch and text. All right. And you choose the location of the letter. All right. And type of the letter you like. I'm sorry. L. This time I'm going to go with the letter L. Point 4. Okay. And then finish the sketch. Extrude. 0.625. That's 1/16 of an inch. Extrusion. Okay. All right. So material. Most important thing is the material, and you choose, please, the same material as you have chosen earlier. Okay. Oh. Control Z. Malleable iron. Yes, that's the material we have chosen earlier. Cool. Okay. Important thing is to note that it's 1 inch diameter hexagon, and internal, its inside is 0.75, 3/4 of an inch diameter hexagon from corner to corner, and this is just going to fit perfectly, okay, to the cap. So save your work, okay. Now create a new assembly drawing this time. All right, let's do that. And click on the new button. And again, in system, but this time is assembly drawing. So standard IAM. Standard IAM. This is, okay, create. Basically, you can go to assembly and you can place the two drawings, okay? And one of them is gyroscope by again. Okay. And escape. open, and the next one is here. All right, so there are two approaches here, and one of them is if you are creating a printable file, you have to position it in a way that the file, two of them is printed in the same drawing. That can be done, okay? Also, you can also insert assembled two parts together, and there are also so it's possible to do this in two different ways. You need to position that, and so I made two copies, okay, just in case to demonstrate how to do either one of them. When you have an assembly drawing and we have two parts inside the assembly drawing, one of the things you can do is go to assembly and use the joint command. Joint command is different than constraint command. Joint command enables you to join two parts, to fit two parts together. The fitting is one of the most important concepts in manufacturing world. The people who are specialized in fitting, for example, in the manufacturing industry called fitters. There's a name for that too. I mean, these are one of the most experienced, high-achieving group of the people in the manufacturing world. Fitters, they know pretty much so much more than the other people. Okay, so how do you fit this part into this part? You're not constraining, because constraints are used during the design field, in the design. This is a fitting. So in order to fit this to here, I'm going to select the body, make sure that the body is grounded so that it's not moving. And I'm going to use the joint command. But what kind of joint is it going to be? That's another thing. There's automatic joint. See if it's going to be able to fit the automatic joint here. So click on the automatic joint. Okay. Click here. And then click the same place that it's supposed to go and see how it's going to be. This is good, but not perfect. So what else can we do? We can cancel this by Control C, and then we can try something else. Joint, okay? We can choose, for example, this corner, then come here and then choose this corner. And see if it's going to be better fit. Yeah, that is a better fit. Okay, and apply. So are we done with this? No, we're not done. Why not? You can move it if you want to. So this is, you can use several joints. Okay, for example, this surface has to be same on lining up with this surface. Okay, that can be done, accomplished too. But ultimately, this is the way it's going to look when it's printed. The question is, how would you like to have it printed? Okay, this is not the way to print this. Okay, this is assembled. This is the way you want to assemble it after it's printed. Okay, and this is the way to use it, perhaps, right? So the question is, when during the time of printing, how would you like to have it printed? I'm suggesting rotate the items. Okay, I'm going to free rotate this, for example, in a way that is better for printing purposes. Okay, so this look definitely This looks better, definitely better. When you're printing something. So the body will look like that, perhaps. Also, we can rotate it. So in other words, free rotate, and we can do this. Ideally, how does it affect process of printing? I think this is the way to do this right now. I think this is the best way. But here, the cap, we have to position the cap also. So I'm going to go and free rotate with the right mouse button on it. Okay. And free move. Okay, so I look from the top view as well. No, I did not like it. And this is not the way it's going to print it because it's not going to look good. When it is printed, it's going to be difficult. This is a lot. I think we should rotate the cap. And free rotate the cap. I think this is best. Probably this is the best way to do this. Yeah. Knowing the way that nozzle, the 3D printer nozzle operates, I'm suggesting, yeah, this is the way to put them together. Right. Mm-hmm. Okay. All right. Thank you very much for your time. I think this is the way it's going to be. You're going to have only one copy. Okay. If you want to 3D print it, just leave it the way it is, like that. Or make two copies like the way I just did, and use the gives you the chance to use joint command. And when you use the joint command, you literally put it together the way things are supposed to be. Computer knows that too. If you want to 3D print it, this is the way it's supposed to be. 3D printable version is .stl file that should be extruded. How do you do that? File export. If you go to file export and then CAD format, you choose .stl model. Okay? .stl model. And then you can just simply say, when you're saving, again, gyroscope, call it gyroscope with your name. Okay. And 3D print should not have the final product, okay? But I'm going to just simply copy this for your eyes only and put it in the design. All right. Thank you, and give me a call if you need help or more information about this, and have a great day.